You ever stop and wonder how an email gets from your phone in London to a server in Sydney in like less than a second? I promise you, it's not magic. It's something called BGP, the Border Gateway Protocol. You can think of it as the secret GPS that's directing every single piece of data across the entire internet. So, how does this thing actually work? Let's dive in.
Okay, so to really get BGP, you've got to think way, way bigger than that little box blinking in your living room. We are talking about a network of networks, so huge it makes your home Wi-Fi look like a single grain of sand on a beach that covers the whole planet. And the rules for a network that big, they're just fundamentally different. And this right here just shows you that difference in scale perfectly. See, your home router, it has one job: send everything out one single door. That's it. Super simple. But a router at a major internet service provider, that thing is like Grand Central Station, but with over 1 million possible tracks, and it has to pick the absolute perfect one for your data instantly. This is the key thing to understand about the internet. It's not one giant single thing. It's this massive, sprawling mesh of thousands of completely independent networks that have all just agreed to talk to each other. So how on earth do they coordinate all of that traffic? Well, they do it through a process that's part tech, part politics, and it's all based on a kind of digital handshake. This is where we get into the real building blocks of the entire global internet, things called autonomous systems and peering. So to manage all this insane complexity, BGP groups huge collections of routers into what we call an autonomous system, or just an AS. The best way to think about it is like a world map, right? The map doesn't show every single street, it just shows the countries. For BGP, Google is a country, your university is a country, your ISP is a country. It's how BGP can even begin to read the map.
And how do all these giant countries connect to each other? Through something called peering. This is the handshake. This is literally the fabric of the internet being woven together, one manual agreement at a time, between two networks that decide to exchange traffic with each other.
You know, what this shows so well is that the internet is not some magical, self-organizing cloud. Nope. It is built by people, engineers physically plugging in cables, and network admins sitting at a keyboard carefully configuring these digital handshakes, telling their equipment, okay, you can trust this neighbor. It's a deeply human process.
And that brings us to this core tension at the heart of the internet. ISPs have to trust their peering partners to send them good, accurate information, but they also can't really trust them because they don't control their neighbor's network. So they apply all these strict filters to protect themselves from bad data. It's this constant state of trust, but verify. Okay, so we've got all these networks connected, they're all sharing information, but with 1 million possible routes on the table, how does a router actually decide which single path your data should take? Well, it is not as simple as just picking the fastest one. Not even close. This is the sheer scale of the challenge. A big ISP router wakes up in the morning with a list of about 1 million possible paths to get to every corner of the internet. And its job is to somehow filter all of that down to just one single best path for every destination. Here's a really great way to think about it. Imagine you're in a stadium with 1 million people, and you have to find one specific person. You're not going to check every single one, right? No way. Instead, you'd use filters. You'd shout, hey, everyone with a red shirt, please leave. Then, everyone who isn't from California, you can go home. You just keep applying filters until only one person is left standing. BGP does that exact same thing, but it uses this incredibly complex tiebreaker list with at least 11 different criteria. And what's wild is that pure speed is pretty low on that list. BGP actually prioritizes business decisions first. It uses attributes like weight and local preference, which are really just fancy ways for an ISP to say, I'd rather send my traffic through this partner because our business deal makes it cheaper for me. And this whole process is so thorough that if, after all of those complex business and technical checks, there's still a tie, you want to know what happens? It might just come down to something as random as which of the neighboring routers has a lower IP address. It's basically an arbitrary coin toss to finally pick a winner. And boom, there you have it. From 1 million possibilities, one single best path is chosen for your data. It's this beautiful, complicated dance that happens in literally the blink of an eye. All right, now we're going to talk about what is maybe the most surprising, most counterintuitive, and honestly, the most important feature of the protocol that runs our super fast internet. So let me just ask you,
What do you think is the most critical feature for a global routing system like this? Has to be speed, right? Or maybe efficiency? Well, the answer is probably not what you think. Get this. The single most important feature of the protocol that powers our lightning-fast internet is that it's slow. I mean, it's deliberately, purposefully, and critically slow. And that's not a bug, my friends. That's the entire point. And here's why that makes sense. Slowness equals stability. See, all across the world, networks are constantly going up and down. Engineers call this flapping, kind of like a flickering light bulb. Now, if BGP reacted instantly to every single one of those flickers, the entire global internet would be in a constant state of chaos. By being slow, by waiting a bit and bundling updates, BGP makes sure the internet's backbone stays stable for all of us. And you can actually see this slowness in the real world. You know, when you register a new website, it doesn't just instantly work for everyone on the planet. It can sometimes take a couple of days for that new route to slowly make its way through all the autonomous systems around the globe. That's BGP, just taking its time to do things right. So BGP is this hidden, trust-based, and surprisingly slow system that holds our entire digital world together. And you know what the coolest part is? You can actually go see it for yourself. Yeah, a lot of ISPs have these public websites called a looking glass. It's like getting a backstage pass to the internet. They literally let you log into their giant routers and see what your own home network looks like from the other side of the planet, through the eyes of an ISP in, say, Japan or Germany. It's a really fascinating peek behind the curtain. Which kind of leaves us with this one last big thought. This entire planet-spanning system, it's all built on people making manual configurations and on these trusted, yet untrusted, handshakes. So what happens when that trust breaks? Well, that's a story for another time. But it really makes you think. The internet is an absolute marvel of engineering, but it's also a surprisingly delicate web of human trust. And that's something we should probably never take for granted.